Hello, this is Dr. K. After I made the video introducing the bounded stack component, I became a little bit concerned that I didn't really do a good job of explaining the abstraction function and the representation invariant. My main concern is that a lot of students will just think that this is scary math stuff that doesn't have any relevance to coding unless you're working with formal verification. Well, that's not really true. In fact, in almost every object we create, we end up implementing an abstraction function. Now, let me explain what I mean by that. In the bounded stack intro video, I gave you this abstraction function for a bounded stack implementation that uses an array and two integer fields. After looking at this for a while, I have to concede that even though someone with a math background might be comfortable with this, it probably doesn't speak to most computer programmers. So let me give you a different way of writing this abstraction function. Here it is all on one line. You've got an open bracket followed by the first element in the array, followed by a comma, followed by the second element in the array, and so on, up to the array element whose index is depth minus 1. Then you've got a closed bracket followed by a colon, and that's followed by the capacity of the stack. Now, if I give you a particular representation, and remember the representation just consists of the fields of the object, if I give you the value of the elements array and the value of depth and the value of capacity, if I give you that representation, how easy do you think it would be to just plug those values into this function and end up with a text string that shows you what the bounded stack looks like? I think it would be pretty easy. In fact, when you write the abstraction function like this, it looks like a pretty good description of how the toString method should work. And here's the beginning of a toString function for the array-based bounded stack. Now let's think about this. It takes all three fields of the representation as input, elements, depth, and capacity, and it returns the abstraction, a string that denotes the bounded stack object. And that's it. So if anyone started panicking while watching the previous video, I hope this return to code will ease your nerves a bit. Well, that's the abstraction function. What about the representation invariant? Well, the representation invariant is just a Boolean expression that tells you what needs to be true in order for a representation to be considered valid. And it doesn't look that difficult to implement as a method either. Is there some programming equivalent to the representation invariant? Well, there is, but it's not something that's used by everyone, like the toString method is. Some developers like to include an isValid method in their classes. The isValid method checks if the values in the representation, the fields, are consistent with a legitimate bounded stack object. One way this can be used is by the implementer of the class as a kind of sanity check. He or she can add assert statements that call isValid at the beginning and end of each method. Now, maybe you don't want to do it for every method, but it's particularly good for methods that are intended to modify the values in the representation. Another way of using an isValid method is simply for unit testing. If you make the method public, tests can be written that check to see if the representation remains valid even after a stack object is modified. Again, it's not as ubiquitous as toString, but you do see it. And that's it for this brief video on the abstraction function and the representation invariant. I hope it made things a bit more clear. Thanks for watching.